Hello. In this screencast, I'm going to go through, on the fly, some ways of getting FFT measures out of Persyst into CSV values. And there are multiple ways to do that. I'm just going to do this stream of consciousness. This is Michael Guest, VP of Research and Clinical Applications for Persyst. And I have a recording open here. This is Persyst running in research mode, but everything I'm going to do, you can do in the clinical product as well. Research mode adds a host of additional tools and some additional capabilities, including batch processing and so forth. But we're not going to use that in this case. So this is the default trend panel versus baseline comprehensive, and we have a number of trends here, some rhythmicity, FFT spectrograms. We're going to focus on those and actually select just these to export. We're also going to do band power, and then we're going to look at Insight 2, which is Persyst 15 as well. This works in Persyst 14. Everything I'm going to do is available in Persyst 14 as well. And of course, we're always happy to join or meet by web conference to answer questions. Let's get started. So here are FFT spectrograms, and I can choose a range of data or just do the whole trend. So I have a seizure here. I expect, of course, we see this brightening up. Higher values here, and I can look at cursor position values just by right-clicking Show Values. I can see what the peak amplitude is at a particular frequency from 0 to 20 hertz here for that. All right, but we want to get CSV values. So let's get started. I'm going to show just the trends, and I can do the entire trend or I can pick a range. Let's 30 minutes. And if you want to do the entire range of trends, we'll just do export from the GUI. And again, with research, you can batch process and batch export CSV values and automate your pipeline and have a trend set up with just the trends you want to be exported to CSV. And those could be quite a few trends if you wish to do that. You're not limited to what's in the default setup. You can customize this extensively. In fact, if I go to add, here's all the existing trends that are built across all the panels. And of course, in the research product, you have a whole host of things. We have documentation on that. But without further ado, let's just jump into it. What I've done is I've used the left mouse button and the control key. You can use shift, and I've highlighted these two. I just want the FFT spectrograms, and these are a linear scale, 0 to 20 hertz. You'll note if you're exporting rhythmicity values, this is not scaled linearly. The lower part of this expanded, upper part is contracted a bit so that you can see higher frequency ranges, but when we're looking for something evolving at lower frequencies, that's why we stretched that out. And if you're doing that sort of research, again, you'd set up trend panels so that if I go into the properties for rhythmicity and I go through this, there's the scale frequency axis with square root. We would turn that off, so we'd have a linear scale. Otherwise, it gets a little tricky to figure out what your bin width is, right? But for review, this is a visual tool, but you can again set that to be optimal for exporting values. But we're just going to do CSV, and by default these are linear, 0 to 20 hertz, and you can change the scale. So if I click on the scale, I can change this. By default, it calculates up to 32 hertz. You can go up to half the sampling rate, but if it's not going to show it, it doesn't calculate that by default, but you can change that. All this stuff is customizable. All right, if I do not set a range and I go to Tools, Export Channel Trend Values, normally one or more ranges. Okay, do you want to do start to end? Say yes, and I'm just going to drop this up on the desktop, and we can open up that in Excel. Now, if I wanted to do a range, I would just right-click and insert range, and it tells me the number of seconds with a little tooltip up at the top here, and I can limit the range of the CSV export, but it's still going to do FFT spectrogram left and right. Now, what do we get from that? Well, I'm going to go ahead and open this up in Excel. So I'm going to ring up Excel, and I should be able to just drag this onto here. There it is. Close that little message, and here's the file name, and here's the information about it. Note that the epic length is 8 seconds. That can be changed, but by default, we're using 8-second epic lengths. They could be 1, they could be 30. This is all adjustable in research, but in the clinical product, these are set. Research product, you can change all the engine parameters. So this is going from the beginning of the recording, that's time 0, and then we're jumping in 8-second increments, and then what we have here is each frequency bin according to the FFT parameters. And these are microvolt values. Over here is Microsoft OLE time, which gives you clock time. It encapsulates both day and time. The fractional part is the fraction of a day after midnight. And this is the number of days from 1971. I'd have to look that up. It's not quite like Unix time, Microsoft OLE. Anyway, that's that. And if I scroll to the right, that was left hemisphere, it was right hemisphere. So I highlighted the left and right hemisphere trends, that's what you get. So let's go ahead and move this out of the way. And again, in the research package, I can go ahead and click Preferences, Trend Preferences, Calculation Engines, and go to FFT Engine 01, View, and I can see here that I've got those frequency bins are indeed half-hertz bins. Again, this is adjustable. But once you calculate this and process it, those values are stored so you can't change them. But getting those values out is super easy. Just again, I marked a range here, so click here, highlight the trends I want to export, go to Tools, Export Channel Trend Values, and I'm going to drop that on the desktop with all my fun stuff on there and replace that file. Oh, because I have it open in Excel. That's okay. I'll just close that. So that's how to do that. Now let's say you wanted to do something custom. Now you can create custom trend panels. I'm just going to add a panel to this, and I'm going to call it spectrogram by channel. Okay. And I could go ahead, and if I already had FFT spectrograms by channel, and I can just scroll down to FFT spectrograms. You don't want to duplicate a bunch of stuff. Oh, look, I've got FFT spectrograms by channel. I go ahead and just select all these and add them to this panel. So those are individual channels. And I can highlight all of these. Left click the first one, shift key, click the last one, set the range, and now I'll get a set of CSV values, 0 to 20 hertz, because that's what's set here. The scaling doesn't really do anything to the export. It's just a visual scaling. Obviously, you don't want to look like that, like this when you're reading. That doesn't change the values. That just changes the scaling for display. I would get bipolar channels. These values, export that as a CSV, and I would have, since this goes to 20 hertz, there would be 40 columns for C3 to P3, 40 columns for C4 to P4, and so on, for the length of the range. That was done every 8 seconds. Easy to do. Now these can be reordered. You can drag and drop these. If I wanted to have these in different positions, you could just drag this bar. Or you can go to Preferences, Trend Preferences, and Panels, and then I could reorder these this way using the up and down buttons. Okay, that's if you want spectrogram values, but let's say you want to have something different. Let's say you want to have band power. Now there is a band power trend here, power by frequency band. This is scaled in a more traditional manner, or should I say just rendered. We're using 2-minute time averaging for these to smooth it out. And you can see this does a pretty good job of finding changes in the power in different bands. This is looking at 48 hertz. We can see this big rise in power here. And of course that's during a seizure. And the seizure evolves from faster to slower, so you can see these are offset a bit. So since it starts faster frequencies, this rises first, and then as it gets slower, this happens later. But these are averaged over 2 minutes, and it's a running average, so what I would do is get a value of the last 2 minutes, shifted by 8 seconds each time. But let's say you want the raw FFT values. You don't want to do it using a time average. Well, again, easy to do. Let's go ahead and create a new panel. And again, I'm not saving these this trend panel add. If you wanted to save this work, you go to Preferences, Modify, you clear the trends, Modify Template, pick your starter template, the default trend settings version P15 or P14.mmx. Make your changes, save it as a new trend panel, and then you can apply it over and over again. But I'm just showing you how to do the export. So I'm not going to bother with this. This is going to be saved with this recording, but if I was going to do this with other recordings, I'd want to create a new trend template to do this. I wouldn't have to reprocess either. I'm not calculating new channel pairs or different parameters. I could apply a modified trend template that has my research trends set up, and I wouldn't have to reprocess as long as I'm not changing the channels or the calculation engine parameters. Easy. All right, so I'm going to do add a panel, and we're going to call this band power by well, I could do it by hemisphere. Let's do it by channel, but I'm going to do we'll start with delta by channel, because again, you'd end up with a heap of channels, right? So I'm going to click that. I'm going to click plus because I've already got band power. And do I have it by channel? FFT power by channel? I do not. So I'm going to start with a base trend. Actually, let's create a new trend. I'll say new, and I'll say FFT power, create trend. And the data, we're going to use this engine that's already created. Again, in research, you can create multiple FFT engines with different epoch lengths. We're not going to get into that at the moment. We'll start with this first channel pair. The spectrum, I want 1 to 4 hertz. And we're good. You can change your power display. We'll just use microvolts. You can use microvolt scale, decibels, or square root. Probably wouldn't use this. That's more of a display convention. Okay. So here it is. It looks very spiky. Let's change that because this is smoothing. So we'll click that. We'll go back into this graph 2D. Let's do a bar graph. That's better. And each one of these blocks is 8 seconds long because I'm looking at 30 minutes. Now, I don't have to create this for every single channel. I could do replicate trend. And I've got these channel lists for left, right, quadrant, anatomical regions. I could just say all channels. And I've already done FP1, F7. I don't need to duplicate that. Click OK. There they are. Exporting these. I'm going to hit Shift, select, highlight them all. Again, if I wanted to do the entire length of the record, I could right-click, delete the range, and now I'm going to get a CSV for that. Let's go ahead and create it so you can see what it looks like. And I'm going to export these channel trend values, use the start record end to end, and I go to desktop and save. Okay, let's bring that up in Excel. There it is. So each one of these is now a channel. Okay, so that's those iterations. It follows what's happening here. Each one of these is by channel. Okay, so once I bring this up, I know that each one of these columns is by channel, and it's incrementing every 8 seconds. It's not time averaging. Those are the microvolt values for each one of those. Easy. So let's say you wanted to do add a panel, you want to do the next band, or if you wanted to do everything, you could just crowd a bunch of trend panels onto one and export them all to CSV. There's no limit to how many, there's not a practical limit to how many trends you can put on. It just becomes difficult to see them, but you can export them to CSV. There's a limit to how big of a CSV file Excel can open. That's okay. All right, so let's do and then we select add new trend because I don't have theta by channel. Go to frequency, FFT power, create trend, and again we'll do our bar. Our spectrum will be 48. Expressed in microvolts, and there we go. FP1 F7. Right click, replicate trend, all channels. There they are. Don't need that, I've already got it. Click OK, there they are. So that's the process of doing that. All right, now let's look at doing this for something a little bit, and you can see these trend panels still. Why is that blank? Oh, easy enough. Scaling 0 to 0. That doesn't really work. Okay, and I could have set that before, but since these are set under master control, I can just click the gain here and change that. Again, it wouldn't affect the CSV output, but it's nice to actually see the bumps. Now, these blank areas, that's where artifact reduction is blanking out that channel. So if I click the EEG, let's see if we can find some places where artifact reduction is saying there's artifact null right there. So that's why you get 0 values. You can turn that off, of course, if you click AR. Then you have the non-artifact reduced data, but you probably want the artifact reduced data. You want the better representation of the cerebral signal in most cases. All right, what's another way you can do this? You can go to Tools and Insight 2. And there's a whole NeoPrism application notes. Let me shrink this down to that little video recording window we have up on the screen. There it is. And size this accordingly. All right. You can pick a montage that makes sense. Now when you're doing power measurements, you probably wouldn't do the recorded, especially if you don't know where the reference happens to be placed. You probably wouldn't do CZ reference because you have different interelectrode distances. You do an average reference, that makes sense. Or you can do a bipolar. And since we expect bilateral symmetry but not AP symmetry per se, then we should pick, let's do this one, bipolar longitudinal A. There it is. So we can display, let's go to the on side of this. There's some built-in tools. So if I click NA here, you can do FFT, delta, theta, alpha, beta map. There's that. We can go ahead and get rid of that stamp. Now if I click properties here, it's doing the current page, data ranges. There's a whole application notes on this. Each page, visible, I could mark ranges, that's fine. If I go to FDA, or frequency domain analysis tab here, there are my ranges. I can change these, add them, save them. I can pick cursor or binned analysis. This is binned analysis, so that's those bins right at the top. What type of windowing you want to use. And you can do all sorts of different stuff. You can do coherence, combined, separated, CSA. You can do phase encoded, Fourier spectrum analysis. You can do coherence. Lots of different tools in here. There's a whole application note on that. But without further ado, we're just doing the current page. And as I go forward, you can see this FFT move as the frequency evolves faster to slower. So let's say you marked a range on this. Again, there's an application note, but let's just go to Insert Vertical Adornment and pick the table because I've already marked these bins. So I've got the delta, theta, alpha, beta amplitude. So I'm getting the CSV values essentially from this, especially if I copy to a clipboard and paste it into Excel or what have you. The other thing you can do is modify what you're doing here. So let's go to properties of this table. That's the average amplitude. You can do sum, peak, mean frequency. Let's do peak frequency as well. So now I'm showing the delta amplitude and the peak. Let's see what's happening up here at alpha for these channels. All right, it's saying that the peak frequency is 12 hertz at this particular point and amplitude 7.3 megavolts. So that's another way to do this. Again, there's a lengthy application note that goes through all of these tools. Go ahead and take that off the screen. And by these tools, I mean the NeoPrism tools that are listed here. You can do wavelets, component analysis, independent component analysis. You can do principal component analysis and correlation, matching pursuit. There's a whole bunch of tools. But we won't get into that because we're getting into the weeds. This answers the question of how do I get CSV values out of Persyst for FFT, either spectrograms, band power, or what have you. Again, this is Michael Guest, VP of Research and Clinical Applications for Persyst. Thank you for watching this off-the-cuff, on-the-fly stream of consciousness exploration of some of these tools. Thanks.